Indian Space Research Organization has postponed the docking of the SpaDex satellites for the second time. The mission that was launched on 31st December 2024 from Sriharikota witnessed an unexpected hiccup in its final leg. ISRO detected that during a maneuver to bring the two satellites closer, targeting a distance of 225 meters, the drift exceeded expected levels following a non-visibility period when the satellites could not be tracked. Now, docking in space involves the precise alignment and connection of two spacecrafts traveling at high speeds in orbit. Both the chaser and the target spacecrafts are orbiting 470 kilometers above Earth, speeds of 28,800 kilometers per hour. Now, to release space docking, the relative velocity between the chaser and the target spacecraft must be near zero. The process requires meticulous planning and execution, as any misalignment can lead to failure. If the relative velocity is too high, the docking attempt can lead to damage or collisions. If velocity is too low, it may take too long to complete the approach, which could lead to fuel inefficiencies. Now, this is undoubtedly an ambitious mission. Till date, only 3 countries in the world have successfully executed this. If we are successful, it paves the way for Gaganyaan and chandrayaan in 4 missions. We'll talk about this with our guest. Ram Srivastava, former ISRO scientist, joins us on the show. Wing Commander S. Sudhakaran, CEO of Q-Gates Technology, also with us on the program. Group Captain V. N. Jha, senior scientist, joins us on the program as well. Group Captain V. N. Jha, I'll begin with you, sir. Sir, obviously, it's become a habit for India to venture and endeavor for the impossible. This is just a very small hiccup. What do you make of ISRO's capacity and its capability in overcoming these odds?
Look, Vinit, what actually happens, there are always a room for uncertainties in space science. Lot many if and buts are there, lot many variables are there. Uh, this is one area which is absolutely new to ISRO. Here, there is one particular satellite is going to go and interface with another satellites. Uh, so there are areas of unknown. Secondly, when you chase a satellite for interfacing with this, like docking with it, uh, uh, then you look at the whole picture. See, right now here there is only one small satellite, just few hundred kilograms, and you compare with the International Space Station, which is thousands of tons of mass there. So there are obviously challenges in a smaller satellite. Secondly, it also depends on what is the technology that they are going to use into the chasing of satellite for the docking. On that day also, I had said I'm not sure what particular technology ISRO has adopted. There are optical technologies, there are laser technologies, there are the multi-purpose linking technologies, which all are there into it, with which you come and close into the target. Now, here in this particular case, uh, uh, the moment you have given a significant drift, which is understandable because tomorrow, when India launches its own, say, rocket carrying the astronauts to the space station that we have there, there will be variables in this of the same order. But here, for the first time, when you are changing a small satellite with another satellite which is trying to close from, initially it was supposed to be 220 meters. Later on, someone said that it will go around 13 kilometers or so adrift. So these uncertainties will be there with the smaller satellites. Uh, Day first today, when I was listening to the one narrative from the ISRO, I could realize that there are small problems. So problems will be there whenever you try something new. And this is something where ISRO is trying something very new. It has never been done earlier. It is not the rocket science, it is not the satellite, it is the docking of one particular satellite, which we imagine, something of the future. we are going to see in the Gaganyaan, we are going to see not Gaganyaan 1, maybe Gaganyaan 2, 3, 4, when Indian space station is coming up there, or Chandrayaan 4, wherein one complex satellite which will be sent to a moon, one particular orbiter will remain, uh, into which the lander will be coming out, and again after picking the samples we will be going back and docking. These are the things where we are looking at. So plenty of variables are there. uh, Still, we have not given up as yet. It is reasonably under control, but variables are there. Let's see how it all happens. To my understanding, they have used a very good technology of docking interfacing. It's the contact technology with which minimal push is there, and then it locks onto, catches onto, latches onto, and seals the entire interface. Uh, we are still looking at it. I'm sure the ISRO is full of scientists. Mr. Ram Shivastav, he's here. He knows how intricately you work out on each problems when it comes up there. It must have been rehearsed here on the ground as well. But in the space, it is altogether a different ball game when you chase a target and close into it, dock to it. I still wish all the best. There are still, many of the hopes that it will go all as a normal. Let's see how it happens. Vinit.
Mr. Srivastav, well, it's a small hiccup. It's been delayed again. This is obviously a challenge, but the fact of the matter is that India has been presented with a number of these challenges in the past as well, and some of them have been bigger. Do you concur that this is perhaps a different kind of a testimonial challenge? Challenge, I beg your pardon, that India has to endure.
Obviously, this is going to be a big challenge, but hopes are still there. We have not left the attempts. The reason is very simple. At present, only the relative velocity is to be controlled. And there are so many parameters, as Mr. Jha has told you. These parameters may vary unknowingly. Sometimes there might be a solar burst coming there. There might be some magnetic storms also disturbing your signals, controlling system, because ultimately we have to chase, we have to send the signal. It is coming reflected one. Then the computer will analyze, calculate how much thrust is to be given to the chaser, and then it will gradually go and meet the junction. Undoubtedly, two satellites, they are not having that much weight. So to just coupling of a satellite or a vehicle, a space vehicle, to a space station is entirely different because of their momentum. The mass is one of the important parameters. But the controlling power of our thrusters, that is very important. How far we can control it and what challenges are coming in that particular process. So these are being analyzed, and I have got very much hope that 70% there is the possibility that we will be very successful. Only 30% is only the first two parameters. They are not coinciding as per our calculations. Now the correction has been made, and I'm sure those corrections will fulfill. At the most, what will happen? Only the life of the conducted satellites will be slightly less than what we have expected. But I'm still very hopeful because the technology which we are using is one of the latest technology. And another thing, it is a totally indigenous Indian product. We have not borrowed this technology from any other company or any other country. So the reason is we have developed it, we have done the laboratory experiments, and we have done simulation, and I'm sure we will be successful in this process. Let us hope for the best.
Akram, this is also an important development. It's an important trajectory because Gaganyaan is obviously, and the confidence that will exude the events leading up to Gaganyaan stems from the successful execution as well as conclusion of these two satellites pairing.
Thank you. In my perspective, I would like to say that these setbacks are very essential These are important learning lessons that ISRO will learn today. Because imagine today there is no sword hanging on our neck. We can do it at our own free time. If it does not happen on 6th, it can happen on 8th and 9th and 10th and so on. But imagine on that day when there will be a human in the loop, when there is a human which needs to be docked. That is the time we need to get everything precisely perfect. We don't need any shocks to come at that time. Having said this, let me quickly tell you what are the challenges in docking such a capsule in the space. There are problems of thermal expansion of materials because of the inconsistencies of temperatures in the outer space. There are communication delays. Sometimes the latency in communication, the telemetrics that comes out of the orbit, it is not exactly what happens there at that precise moment. There are delays, there are distortions in communications which we need to handle. Then impact of microgravity, because we don't understand, the objects don't react to commands or forces exactly they do the way they do on Earth. So there is this problem of microgravity related issues. Then when high speed maneuvering targets, combined with microgravity, sometimes when you apply the brake, it doesn't go and stop at the exact same space. Or when you accelerate, it doesn't accelerate to the same speed that you desire. It could be over, it could be under, and these are, critical issues. Drift management. Sometimes it goes out of orbit. It doesn't exactly stay on the precise intended orbit, because of which these docking issues happen. And then there are non-visibility periods, because sometimes these satellites are not visible to the ground stations, because of which we are not able to accurately estimate their orbit or their parameters, based on which we can take a decision. So therefore, we will have to take things lying down. Now, what happens is, while we know that these are the variables, sometimes there are variables which arises out of the complex relations, or how these interact with each other. It gives rise to new situations, and these are things that we learn as we do these experiments today. That is precisely why this particular experiment is being carried out, and I'm happy that ISRO is not being successful in its first attempt, because success has many fathers, failure has none. And it is in failure that you learn a lot. It is not in success, because in success you tend to believe that you're perfect. And then there comes that hole which sometimes sinks a big ship in the midst of an ocean. That's what happened to the Titanic. So I'm happy that ISRO scientists are getting to learn. Probably the gods are with us. The gods want us to learn. And this delay, I take it as a feather in our cap. We are able to get stronger in our resolution to build our own Bharat Antariksh station, which will enable the generation next to probably do space tourism from there, and so on and so forth. Thank you.
What's next once this docking process is successfully completed? What do you think that the Indian space program is going to be up to next? Of course, we all know how Sunita Williams has been stuck in space for a few months now. And India is very gradually but very successfully entering clubs that only 2 to 3 countries have occupied so far. Do you think this completion is also going to put another illustrious feather in that hat that we have had the pleasure to cover with you as well?
Is that question to me?
Yes, sir.
Okay. Now, before I come to that, what is going to happen subsequently, let me just explain to you one more thing, Vineet, what I was very critical on that day when it was being launched. When I heard that the present chaser has got only 2 motors. In SpaceX, they call it Crew Dragon. There are 24 motors. And why it is there for? We have all heard about 3 planes, XYZ planes. That is the linear plane. But what happens if there is a rotational plane? So in space, all these are intricate things. So 3 plane are XYZ of the linear, both plus and minus, that means 6. And there are 3 planes in the rotation as well. While it is the chaser is trying to go onto the target, it may just rotate slightly, and that's gone. Even if it is rotated by say zero point 0.5 degree or 1 degree, it is gone. It will not, fit in there. It will not dock. So all three rotational axes also have got plus minus. That is how there are 12 axes. So when you are working towards the 12 axis, you have to have 24 motors. That is the minimal. And when I heard that only two motors, I said, okay, possibly ISRO is trying to, play the game as a something. They are very confident about it, but I was not confident even on that day. See, even if this chaser is there, target is somewhere else, chaser is somewhere else, but 13 kilometers, 12 kilometers, it may be up, it may be down, it may be trying to close in and slightly rotates, it will not fit. These were the intricacies that were there, and these are the challenges. I'm sure ISRO must have worked it out. They must have done plenty of simulation or animation before sending all this with the two motors. That is one thing. Now, how it happens in the say with the future perspective of the ISRO or the space, travels and other things. Look, this docking is one business that is going to hammer out a lot of things. Right now, say International Space Station there. For that, there are the passengers or the supplies going to be sent. It is being sent regularly by both SpaceX, NASA rockets. There is one more agency in US, and of course the US Russians. They are also going to send the thing. But then the ports are different. Russians have got their, for the Zvezda, Russians have got a different port for docking. NASA has got a different port for docking, and SpaceX has got their own port for docking. And if one is roughed up, if the contact is harsh or at an angle, it is gone. It is done with. So they have always two ports for themselves. So that is the intricacy of this particular item is going to be docking. That is one aspect. Tomorrow, Gaganyaan, of course, is the only one capsule in which there is no extra vehicular maneuver. They will not come out of the vehicle. And as it goes, the entire thing will come down. It will come and splash. There is not much of problem. It's a rocket science. Don't go by my saying that not much of problem. There are plenty of problems. That is why all these times are being taken up there. But subsequently, when we go for Chandrayaan 4, all these issues will come up there. And as Wing Commander Sudhakar has told you, if in science, we don't take it as a failure. It is always a learning curve. And you rebound with the many more options to deal with a single problem. That is the beauty of science and technology when you are having something what usually people call it failure, but we say that it was unsuccessful in that particular attempt. So ISRO is going to come up with all new things that is going to be there in the future in the Chandrayaan 4. And secondly, look, there is one more area for ISRO right now opened up, and that is the uh, uh, space travel. Space travel is going to be taken up, like people like Wing Commander Sudhakaran or someone else, they may be venturing into it, and that's a huge market. Once this Gaganyaan goes through, it's only going up and coming down. Like many other right now are practicing there in the world. Two agencies are there. I think one is the blue. Two are there who have gone up there in the sky. Blue Origin, and there is one more. They just go there and come back. In that, there is an exposure of about 2.5 minutes of the microgravity. And just for that microgravity of 2.5 minutes, people are spending to the tune of $240 million. So that is the sort of things that you look for. India, when it comes up there, that space travel is going to be a very big business, and ISRO must concentrate onto this. Secondly, now there is a change of the leadership in the ISRO there. Mr. Somnath will be retiring, and another person will be coming up there. You know, but the process is the same. The motion of the ISRO is same. All directions are already there. So they only will be coming up there to do little more precisely what they have been earlier doing it there. So uh, I can only wish ISRO the very best of all. And this particular experiment is very, very crucial. There was one more experiment that they have grown up, some seed into the leaves that come up. That's something anywhere, even in the vacuum, you put a seed into the soil. Most probably, the root will come
Take
out.
concluding thoughts from Mr. Srivastav and Wing Commander Sudhakar. We have completely run out of time as well. Mr. Srivastav, concluding thoughts from you.
Here, the fact is there, as Mr. Jha has suggested, there should be more engines. In fact, the gyroscopic controlling has been developed. It is indigenous technique, and that is going to be very successful. I am still very hopeful. The reason is we have taken all these points well in advance in consideration. Only problem at present is some parameters are there which is not able to reduce the relative velocity as per usual calculation. Now the new calculation has been done and the command is being released, and I'm sure that will be very successful. And soon we will hear this news that docking is perfectly done. 70% chances are there. Only 30% chances of unknown and mysterious activities they may take place in zero gravity. That part is still there. So let us hope that it will be very successful. Thank you very much.
Wing Commander Sudhakar.
I could only be happy that we are getting to explore new boundaries. We expanding our frontiers, and as India continues to push boundaries in space technologies, missions like SpaceX demonstrate the country's growing capabilities and ambition to lead into the next era of space exploration and possibly commercial ventures as wished by Group Captain Jha. I hope one day I also take to space as a tourist and probably set up hotels in space for our countrymen.
Correct.
And then, bring in a new realm of business for India, because we need to fire on all guns and earn money from all quarters so that billion men in India sleep with 3 square meals a day, don't need to worry about their health and education, and we become that Sone ki chidiya that we once were. Space will pay the way for that.
Well said. A good way to conclude this, very important discussion on India's space journey. We'll take a short break on that note. Be right back.